Hello students, today we are going to see calculus of residues in complex analysis. This is part 3. Already I have posted 2 videos in this topics. Kindly go through that. This is the third part, okay. The problem today what we have is we are going to find the residue of e power z by z squared into z squared plus 9 at its poles. So very first we have to find the poles. How to find the poles? We have to take the denominator term and equating that to 0, find the roots. Those roots are called the poles. So equating this term equal to 0 means z squared equal to 0 or z squared plus 9 equal to 0. Z squared equal to 0. Product of two terms equal to 0 means any one term equal to 0. So either z squared is equal to 0 or z squared plus 9 equal to 0. Z squared equal to 0 means it has two roots 0 comma 0, and this equal to 0 means z squared plus 9 equal to 0 means z squared is equal to minus 9. This minus 9 can be written as 3 into I squared, 3 squared into I squared. Am I right? 9 can be written as 3 squared and minus 1 can be written as I squared. So z squared is equal to 3 squared I squared. Therefore, z is equal to plus or minus 3i. So the roots what we have is 0, 0, plus 3i and minus 3i. These are the poles what we are getting. Since 0 is repeated twice, this is a double pole. Double pole. So single 0 we can say 0 is a double pole. That we can mention. Double pole na another 0 two times we have. Okay, so 0 is repeated twice means we can call that pole as a double pole. This is coming one time now. So these two are simple poles. So 0 is a double pole and 3i and minus 3i are single poles. So 0 is a double pole and 3i and minus 3i are simple poles. We saw one result in my previous video. If A is a pole of order m which is greater than 1, if it is not a simple pole, this result is applicable. So m is the value what we are getting. For example, 0 is a double pole, we got no, 0 is repeated twice. So in this example, m is equal to 2. Okay, if it is like this means leaving that term in the denominator. For example, z0 is the double pole. So 0, z minus 0 the whole squared, leaving that term, other terms you have to treat as g of z. Okay, the formula is g of m minus 1 into a by m minus 1 factorial. This m minus 1 is g of z has to be differentiated m minus 1 times. Okay, I will explain this in this problem. Okay, so make a note of this result. If it is not a simple pole means we have to use this result. Okay, come to the problem here. 0 is a simple double pole. So we are going to find the residue of f of z at the pole 0. This is the first step what we are going to do. Since 0 is a double pole, what is f of z? F of z is equal to e power z by z squared into z squared plus 9. Leaving this term alone in the denominator, take all the other terms as g of z. So g of z what we are getting is e power z by z squared plus 9. This can be rewritten as e power z by z squared plus 9 whole divided by z squared. Originally we have this term. This one we are rewriting in this way because in the denominator we have to take the pole what we are getting. That factor will come in the denominator. Z squared can be written as z minus 0 the whole square. 0 is a pole, no. So z minus 0 the whole squared. Since it is a double pole, z minus 0 the whole squared will come in the denominator. So அந்த மாதிரி நம்ம கொடுத்த term rewrite பண்ணிக்கிறோம். நமக்கு அந்த ஃபேக்டர் எது போலோ அதோட ஃபேக்டர் மட்டும் டினாமினேட்டரில் வச்சுட்டு மீதி இருக்கிறது எல்லாத்தையும் நம்ம g of zன்னு எடுத்துக்கிறோம். ஸோ நம்மளோட g of z e power z by z square plus 9. இங்கே m என்னது? It is a double pole. So m takes the value 2. So what is the formula for residue? G of m minus 1 of a by m minus 1 factorial. That is the formula we have. No, here m takes the value 2. Okay. So on substitution of that, we are getting g of 2 minus 1 is 1 of a. What is a here? Pole 0. 2 minus 1 is 1 of a by m minus 1 factorial. That is the formula we have. No, here m takes the value 2. Okay, so on substitution of that we are getting g of 2 minus 1 is 1 of a. What is a? 2 minus 1 is 1 of a by m minus 1 factorial. That is the formula we have. So on substitution of that we are getting g of 2 minus 1 is 1 of a by 1 factorial. So g of z first we have to differentiate this with respect to z once. So ஒரு தடவை g of z first differentiate பண்ணுங்க. பண்ணதுக்கு அப்புறம் z இருக்க பிளேஸ்ல அந்த போல் எந்த போலோ அதை சப்ஸ்டியூட் பண்ணணும். So first step we have to differentiate this. Differentiate பண்ணுறோம் அப்படின்னா நியூமரேட்டர்லேயும் நமக்கு ஒரு டேர்ம் இருக்குது, டினாமினேட்டர்லேயும் in terms of z இருக்குது. So u by v method. u by v method என்ன ஃபார்முலா? v squared v du minus u dv. டிஃப்ரென்சியேஷனுக்கு தானே ஃபார்முலா u by v க்கு. ஸோ இந்த ஃபார்முலா யூஸ் பண்ணி நம்ம g of z டிஃப்ரென்ஷியேட் பண்ண போகிறோம். இஸ் தட் கிளியர்? ஸோ டிஃப்ரென்ஷியேட் பண்ணலாமா? g dash of z is equal to denominator termோட whole squared, whole squared, then denominator into e power z differentiate பண்ணா e power z minus e power z அப்படியே வச்சுக்கணும், இதை நம்ம differentiate பண்ணுவோம் 2z. So which is equal to z squared. இதை simplify பண்ண வேண்டாம் because நம்ம என்ன பண்ண போகிறோம், we are going to replace z by 0. g dash of 0 only we are going to find, no, so no need to simplify that, just replacing z by 0. So this is 0 plus 9 e power 0 minus e power 0 into 2z into 0 by 0 plus 9 the whole square. 0 plus 9 is 9. 9 into e power 0 is 1. This is 1, but this is anyway 1, but into 0, so the total term will become 0. So this is 9 into 1 by 9 squared. 1 9 we can cancel. So 1 by 9 is g dash of 0. So what is the formula we have here? G dash of 0 by 1 factorial. That is the final answer for residue. So it is residue of f of z at the pole 0 is equal to 1 by 9 by 1 factorial. So on the whole it is 1 by 9. Is it clear up to this? The next term what we are going to find is, we are going to find the residue of f of z at the pole 3i. Here we are not going to use the same formula what we use here. Here f of z is of the form e power z by z squared plus 9. No, already we saw one result. I'll show you what is the result. This is the result. If you have a numerator by denominator term, means the formula what we have is residue of f of z at the pole a is equal to h of a by k dash of a. Using this already we have done one or two problems in my previous video. Kindly go through that. So or else easily you can see this also. But when you apply, you have to make sure h of a is not equal to 0 and k of a equal to 0. So we are going to use this one here. So here it is, take this as h of z by k of z. Okay. So residue of f of z at the pole 3i is equal to h of a by k dash of a. So first we have to find what is k dash of z. Then we have to find what is k dash of a. After that we have to, okay. I think I have missed z squared here, right? Z squared into, okay. So k of z is equal to z squared into z squared plus 9. So இப்படியே வச்சு நம்ம differentiate பண்ணா again uv method use பண்ணணும். Better we can multiply this inside k power 4 plus 9 z squared. இப்படி multiply பண்ணி simplify பண்ணி வச்சிட்டிங்கன்னா அப்படியே directா we can use the differentiation formula. Okay. So multiplication இப்படி வச்சுக்க வேண்டாம். uv method நம்ம avoid பண்ணுறதுக்காக இதை பண்ணுறோம். So differentiate பண்ணிங்கன்னா 4z cube minus 9 into 2, sorry not minus, it is plus 9 into 18z. Okay. So this is k dash of z. After k dash of z, we have to replace z by 3i. That is the formula h of a. h of a means inge h of 3i, k dash of 3i. 3i in substitute பண்ணணும். So k dash of 3i is 4 into 3i the whole cube plus 18 into 3i. So 4 into 3 cube I cube plus 18 into 3, 54i. 3 cube is 3 3s are 9, 27. 27 into 4, that is 108 I cube plus 54i. What is I cube? Already I told you I cube is equal to minus I. How we are getting this? I cube can be written as I squared into I squared is minus 1 into I, so on the whole it is minus I. So I cube is equal to minus I. So when I replace that here, 108 into minus I will come. That minus sign I am writing at the front. Plus 54I. Adding these two, I am getting with the sign 108. This is 108 minus 54, minus 108I plus 54I, which is equal to minus 54I. This is K dash of, this is not Z, K dash of 3I. K dash of 3I is here, no? K dash of 3I. And H of 3I we have to find, no? H of Z is equal to e power Z. So H of 3I is equal to e power 3I. Already we know the formula. E power I theta is equal to cos theta plus I sin theta. So e power 3I is equal to cos 3 plus I sin 3. This is cos 3 plus I sin 3. Okay. Therefore, residue of f of z at the pole 3I is equal to cos 3 plus I sin 3 by this one K dash of 3I, what we got, minus 54I. Okay. Usually in the denominator we are not supposed to take I. We have to take that to the numerator. So already we know the formula 1 by I is equal to minus I. So for this 1 by I can write minus I into cos 3 plus I sin 3 by minus 54. Only I am taking I, no, that is minus I. So minus we can cancel. I into cos 3 plus I sin 3 by 54. This one further நீங்க simplify பண்றதானாலும் பண்ணலாம். I உள்ள multiply பண்ணிக்கோங்க. I into cos 3, I into I squared, that is minus 1 into sin 3, that is minus sin 3 by 54. இதில் real part முன்னாடி எழுதுனீங்கன்னா minus sin 3 plus I cos 3 by 54. இது further நம்ம simplify பண்றதானாலும் பண்ணிக்கலாம். இல்லைன்னா or else you can leave up to this. Okay. So further simplification, if you want, you can. Okay. So this is the residue of f of z at the pole 3I. What is the next pole we have? Minus 3I, right? So next we are going to find the residue of f of z at the pole minus 3I. The same formula, h of minus 3I by k dash of minus 3I. Already we got k dash of z. No, in that I have replaced z by minus 3I. This is equal to 4 into, this can be rewritten as minus 3 the whole power 3 into I power 3. This I have splitted into minus 3 separately and I separately. So minus 3 the whole power 3, I power 3. This is plus into minus 54I. Okay. Which is equal to minus term the whole power 3 means that term will be in minus sign. Am I right? So 4 into minus 3 cube is 27. I cube is minus I. Already I told you, no, minus I minus 54I. Minus into minus plus. This is 108 with the positive sign. 108I minus 54I. When we add, we are getting plus 54I here. Okay. The next one is h of minus 3I. H of z is equal to e power z. So h of minus 3I is equal to e power minus 3I. Already we know that e power minus I theta is equal to cos theta minus I sin theta. So which is equal to cos 3 minus I sin 3. Therefore, residue of f of z at the pole minus 3I is equal to, this term will come in the numerator, cos 3 minus I sin 3 by, in the denominator, plus 54I. This I, when it comes in the denominator, we can take that as minus I. Minus I into cos 3 minus I sin 3 by 54. When I multiply this inside, minus I cos 3 minus into minus plus I into I squared sin 3 by 54. I squared is minus 1. Am I right? So which is equal to minus I cos 3 minus 1 into sin 3 by 54. Both are having minus sign common, so minus can be taken out. Minus of cos 3 plus sin 3 by 54. So this is the residue of f of z at the pole minus 3. Is it clear? The next problem is we are going to find the residue of z e power z by z minus 1 the whole power 3 at its pole. So how to find the poles first? Z minus 1 the whole power 3 equal to 0. Equating this to 0, we are getting z equal to 1 3 times. So this is a pole of order 3. Since z equal to 1 is repeated 3 times, we can say z equal to 1 is the pole. But the order of the pole is 3. So order of the pole 3 means what is the formula for finding the residue? So residue of 1, right? Which is equal to, already we know, no, g of m minus 1. Here m equal to 3. M minus 1 means 2 of 1 by 1 factorial. First we have to find what is g of z. G of z, what I said, the pole என்ன term இருக்கோ அந்த term தவிர மீதி இருக்கிறதெல்லாம் g of z. இங்க denominatorல நமக்கு pole இருக்க term மட்டும்தான் இருக்கு, வேற எதுவும் additional இல்லை. ஸோ இதை விட்டுருங்க, விட்டுட்டு மீதி என்ன term இருக்கோ. நம்ம போன ப்ராப்ளத்தில் பார்த்தா ப்ராடக்ட் 2 term இருந்தது. ஸோ z ஸ்கொயர்டை மட்டும் நம்ம கீழே வச்சுட்டு மீதி எல்லாம் நியூமரேட்டரில் வச்சுட்டோம், அப்படி தானே? பட் இங்கே அது ப்ராசஸ் கிடையாது. ஒரே ஒரு டேர்ம் இருக்கனால நியூமரேட்டரில் என்ன டேர்ம் இருக்கோ அதெல்லாம் தான் g of z. So g of z is equal to z into e power z. So இந்த டேர்மை நம்ம twice differentiate பண்ணணும், சரியா? பண்ணலாமா? So g of z is equal to z into e power z. So இந்த மாதிரி இருந்தாலே நம்ம என்ன பண்ணுவோம்? uv method, because u is z, v is. So differentiation of uv is equal to u dv plus v du. So ஒரு டேர்மை நம்ம அப்படியே வச்சுப்போம், z e power z differentiate பண்ணால் e power z தான். Plus e power z அப்படியே வச்சுக்கலாம், z differentiate பண்ணால் 1. So z e power z plus e power z. Correctா? So z e power z plus e power z. Both are having e power z common, no? So e power z நான் common எடுத்துட்டேன் அப்படின்னா z plus 1. இதை நம்ம second time differentiate பண்ணணும். This is g dash of z, right? G double dash of z we need, because this we want to calculate, no? G2 of z. G2 of z. Actually நமக்கு என்ன வேணும்? G2 of a. என்றது 1. இதுதான் நமக்கு வேணும். அதுக்கு நம்ம G2 of z calculate பண்ணிட்டு zல 1 replace பண்ண போகிறோம். So G2 of z என்றது நம்ம gயை double time differentiate பண்ணுறது. ஸோ ஒரு தடவை பண்ணி இங்கே வச்சுருக்கோமா? இதுலேயும் நான் uv மெத்தட் தான் எடுத்துக்க போகிறேன். இதை u, இதை v. ஸோ e power z அப்படியே வச்சுக்கலாம். z plus 1 பண்ணிங்கன்னா 1 plus 0 plus z plus 1 அப்படியே வச்சுக்கலாம். e power z பண்ணிங்கன்னா e power z. So which is equal to e power z, 1 plus 0 is 1 plus z plus 1 into e power z. This is my second derivative, right? That is g2 of z. In this I am going to substitute the pole. What is the pole we got? 1. So it is g2 of 1 equal to நம்ம double derivative calculate பண்ணதில் 1 கொடுத்தா போதும். So e power 1 plus 1 plus 1 into e power 1, which is equal to e power 1. 1 plus 1 is 2 e power 1. Right? So finally it is 3 into e power 1, or simply we can write 3e. Now come to the formula. What is the formula we said? This is the formula, no? So 3e we got by not 1 factorial, it is 2 factorial. இங்கே என்ன இருக்கோ அதுதான் factorial வரும். That is mistake, right? So 2 factorial by 2 factorial, which is equal to 3e by, what is the value of 2 factorial? It is 2. So this is the residue of f of z at the pole 1. Is that clear? Thank you.